So now that we have our basic definitions down, we'll head into sort of the more basic operations of matrices, which include adding, subtracting, and then multiplying by a scalar. So once again, we're really just looking at what matrices are in these couple videos and just kind of what we can do with them to get some of the basics down. So first of all, let's go ahead and just define a few different matrices that we're going to be using in this next section. So let's go ahead and say A is going to be the matrix 1, -3, 0, 2. The next row is going to be 5, 1, 3, -4. And then the next row is a -2, 0, 3, and -5. So as a review, this is a 3 by 4 matrix. So that's A. We're also going to use another matrix B, which is also going to be a 3 by 4 matrix. So it's going to be 0, -1, 1, 4 in the first row. The next row is 2, -3, 0, -5. And then the final row is 2, 3, -4, -1. This one's also a 3 by 4. And then the final matrix I want to use, I'll call C. This is going to be a 4 by 2 matrix. So it's going to be a little bit taller, but not as wide. 1, 0, -1, 2, third row, 4, -3, 3, -2. Now, keep in mind, there's nothing you have to do to any of these matrices. You don't have to add the numbers, multiply them. It literally just is a list of numbers or an array of numbers. And this is a 4 by 2 matrix. Okay. So here's what we're going to do. We're first going to add A plus B. So what this means to do is we're going to take A, 1, -3, 0, and 2, 5, 1, 3, -4, -2, 0, 3, -5. And then we're going to add B. And so what's nice about adding is that it sort of works the way we probably want it to work. You identify the matching terms, so in this case the 1 and the 0 will be added, and you just add those together, the -3 and the -1, etc. So what I end up with is the matrix 1, -4, 1, 6, 7, -2, 3, -9, and then the final row I would end up with this. And so that would just be my final answer. So all I did was I just took each matching term and I added those together. So for example, if I were to look at one spot in this matrix, let's say the 3, 1 position, I took A3, 1 and I added B3, 1. And so that would give me the third row, and the first position was -2 for A, and for B was 2. And so that's how I got that 0. But I just did that for each of them. So it works out the way you would kind of want it to work out. Also, this might remind you a little bit of vectors where we added the x components and then the y components. It's just now with matrices we have a lot more components to add. It's not just x and y. Okay, let's talk about scalar multiplication now, and I'm going to use my C vector. So let's just say I did let's do, I don't know, 3 times C. Yeah, 3 times C is fine. So this means I'm taking 3 and I'm multiplying it by this matrix 1, 0, -1, 2, 4, -3, 3, -2. And all we have to do is take that 3 and distribute it to every single term, just like we did with vectors. So that's going to distribute. So what I end up with is just 3 times 1 would be 3, 3 times 0 is 0. Go ahead and do the rest of them. 3 times 4, negative 3, oops, and negative 6. And so there's my final answer. So hopefully it doesn't seem too difficult. If you're still struggling with matrices, it might be a little bit difficult, but you will have a chance to practice this skill. Adding works just by adding their corresponding components, and scalar multiplication works by distributing that number to each. Now let's go ahead and combine these two operations. Let's say I had 4b minus 2a. I didn't actually talk about subtraction, but it works the exact same way as multiplication. So I'm going to find 4b. That would be 4 times 0, negative 1, 1, 4, 2, negative 3, 0, negative 5, and then 2, 3, negative 4, negative 1, minus 2 times a, 1, negative 3, 0, 2, 5, 1, 3, negative 4, and then negative 2, 0, 3, negative 5. Oops. Yes, that's correct. All right. And so then multiplying all this out and subtracting everything, we would end up with 4, negative 4. Oops. I already made a mistake. 0, 4 times 0, 0, negative 4, 4, 16, 8, negative 12, 0, negative 20, 8, 12, negative 16, negative 4, minus 2 times 1 is 2, 2 times negative 3, continuing this along. Hopefully you're getting the idea. And then combining all of those, I end up with the final answer of negative 2, 2, 4, 12, negative 2, negative 14, negative 6, negative 12, and then 12, 12, negative 22, and 6. So there you go. It does get a little bit tedious when you have larger matrices. I probably won't make you do anything too heinous here with, like a 20 by 23 or something would be awful, but that's how you do it. Okay, before we end this video for adding and subtracting and scalar multiplication, a couple of rules. What I've kind of been avoiding is the topic of maybe a plus c. So if you were to try a plus c, a and c have different orders. A was a 3 by 4 and C was a 4 by 2. So they have different orders, and this is just impossible. You can't actually do it. No solution. So they must have the same order. Matrices must have the exact same order. It can't just share one number. You can't have a 3 by 4 plus a 2 by 4. They must have the same order in order to, no, let's not use that word again. They must have the same order to add or subtract them. If not, then it's impossible and there's no solution. Okay, so we've covered adding and subtracting matrices. We also multiplied them by a scalar. The next video, we're going to talk about what matrix multiplication looks like. So we're actually going to multiply A times B and etc.